Hi again. So we have reached exercise 6, which is about to trace quicksort and the heap sort. So we have an array, a table, and we need to do the quicksort and heap sort, and then to discuss the efficiency of both elements. So we have this array, and for the quicksort, we know that we need to pick the pivot and then to subdivide the array into and arrange the element into a subarray that is less than 9 and then a subarray that is greater than the pivot. So let's start. Here we have a 9, which is the pivot, and if you remember, we have here an index which is called left and index called right. So we check 15 is greater than 9, so I stop, and then I have 8 on the right, so 8 is less than 9, so I swap both these elements. So I have here 8 and 15, and then I would increment left and decrement right. So 5 is less than 9, I will increment. 7 is less than 9, I will increment, and then I have 11, which is greater, I will stop. 10 is greater than 9, I will decrement. 4 is less than 9, so I need to swap, and then I will decrement and increment. So now the right is here, which is equal to 4, so I swap the pivot with 4, so I would end up with 4, 8, 5, 7, and 9. So now 9 is correctly placed, and I have here 11, 10, 13, and 15. So I finish now the left part and then start with the right part. So now I will pick the pivot as 4, and again I have a left and right. So on the left, 8 is greater than 4, I will stop. 7 is greater than 4 is very good. I will decrement right. 5 is greater than 4, everything is okay. 8 is greater than 4, I will decrement. Now I have finished. They are crossed, and then I swap the pivot with the right, so I will swap 4 by 4, and 4 is now correctly placed. Now I don't have a left array, I just have a right array. So again I will pick 8 as a pivot, and again I have a left here and a right on the 7. So 5 is less than 8. I would increment left. 7 is also greater, so I would increment it. So now they crossed, and then I will swap the pivot with the right. So I will swap 8 with 7. So I will write it again, and then I will swap these two. So I will have 7, 5, and 8, and now the pivot 8 is correctly placed. Then I have the left array because there is no right array. I need again to redo the same stuff. So I will pick 7 as a pivot, and we have 5 left and right on this. So 5 is less than 7. I would increment the left. Now left and right, they swap. I need to swap, they cross, sorry. I need to swap 5 with the pivot because 5 is pointed by the right. So now I place 5 here and 7, and the pivot 7 is correctly placed. I have ended with just one element. So next iteration I have just 5. So I have no left and right, it's just an element. So 5 is correctly placed. So as you can see, now we have 4, 5, 7, 8, and 9 that are correctly placed. And now I move to the right side. So again, I will pick 11 as a pivot, and we have a left here and a right here. So 10 is less than 11, I increment left. And 13 is greater, I would stop. 15 is greater than 11, it's very good, I would decrement right. 13 is greater than 11, I would decrement. So now right and left crosses, and I need to swap the right by the pivot. So I have 10, 11, and 11 is correctly placed, and 13 and 15. And now I need to finish the left and then finish the right. So obviously I have just one element, so I would finish it in one step, and now 10 is correctly placed. Next I will move to the right array, which is 13 and 15. So I will pick 13 as a pivot, and I have left here and right here. So on the left we have 15 is greater than 13, so I would check the right one. So right 15 is greater, I would decrement right. Now so left now crosses right, so I will swap the right with the pivot. So 13, I will swap it with 13, so 13 now is correctly placed, and I have 15. So on the next iteration I will have 15 correctly placed, and now I will have the sorted array, which is equal to 4, 5, 7, 8, 9, 10, 11, 13, and 15. So this is the trace for the quick sort. So let's do now for the heap sort. So I have here the same array, so I will move it till here and do the heap sort. So again, I will do it in both ways. So either we are adding each element at a time into a heap, or we consider the array to heap and then rectify it in order to verify the heap. So let's start with the first method where we add each element to the heap. So first we have 9. It's not writing, I don't know why. So now it's writing. So 9. And then I will add 15, so I need to percolate up. So now 15, 9, and then I will add 5. So 5, it's correctly placed. 7, again, it's correctly placed. Then I have 11. So 11, it would come here. So I would percolate it directly. And then we have 4, it's correct. And then we have 10, so it will come in place of 5. And then we have 13, so here I will need to redraw the tree, so it's equal 15. So on the right side there is nothing can change here. So we have 13, so 13 is here, so I need to place 13 here. So obviously 9 would remain at its place, 11 and 7. And then we have 8, and 8 is correctly placed, and this is the heap once done. And then we need to do the heap sort. So let's do the heap sort. So the maximum is equal to 15. So I would place it at the end of the tree here and replace it by 8. So let's start. We have 8 here, and I will draw all in red. 11, 9, 4, and 5, 7, and here we will have 15. So 15 is correctly placed. Now I need to percolate down 8. So I would pick the maximum, so which is equal to 13. So on the right side everything is okay. So even if I here I would get down 8, I need to percolate up because 8, there's 11 here. So 11, 9, and we have 8 and 7, and we don't forget that 15 is correctly placed. It's the maximum here. So now what I should do is that I will swap 7 by 13. So let's do it. So you've already noticed that in a QuickSort we didn't take that much space and the iterations. So let's do it. So we have in red, or let's place it in blue. So we have 7 here, and we have this 3. Now we have both elements here are in green because are correctly placed and they are not counted in the tree. So we have 7, 4, so I need to pick the maximum. So obviously those one will remain the same because we have 11 here. So so let me copy all these, and then I will do the percolate down. So I will get 11 to the top, and then again I need to percolate down 7. So I will pick the maximum, which is equal to 9, and I will keep here 8 and 7. So I will not carry with me the maximum numbers. So this is now a maximum heap. Now I need to take the last element of the heap and swap it with the 11, and I will remove 11 from the heap. So I have 5 here, 9, 10, 4, 8, and 7. So I need to percolate down 5. So I would have 10 above, so those on the left side will remain the same, and 5 and 4. Now I remove 10 and I would swap it with 4. So I have 4, 9, 5, 8, and 7. So I need to percolate up 9. So I need then place 8 and 4 and 7, and then I would swap 8, 9 with 7. I have 7, 8, 5, and 4. So again, it's not a maximum heap. So I have this after percolating down 7. So again, I would swap 4 and 8. I will end up with 4, 7, 5. So again, this is not a maximum heap. So this is now a maximum heap. I would swap 7 and 5. So I have 5 and 4. So it's a maximum heap. I will swap 4 and 5. And I have 4, and then this is it. So what we have done, so we have sorted the array, and it took us a lot of work. So if I need to continue with the green one, so let me pick the green. So you check how many steps we have. So we have 13, 15, we have here 13, 15, we have here 11, here we have 10, 11, 13, and 15, and here we have 13, 15, 10, 11, and 9. And here we have 13, 15, 10, 11, 9, and we have here 8. And here we have 13, 15, 10, 11, 8, 9, and here we have 7. And for this last one, we have 5 here, 7, 8, 9, 10, 11, 13, and 15. And we have now the array is sorted, because if we write this tree as an array, so it's equal to 4, 5, 7, 8, 9, 10, 11, 13, and 15, and it's sorted. So let's I will not do the second part. I will keep it for you as an exercise, so you just consider the array as a heap. So I will do just the part but without the sorting. So we have 9, 15, 5, 7, 11, 4, 10, 13, and 8. So we need to rectify this in order to be a maximum heap. So we start from the first non-leaf node. So the first non-leaf node is equal to 7, and I need to rectify this tree. So obviously this part is not a heap, so I need to calculate up 13. So here we have 13 and 7, and then I will check 5. So 5 is not a heap here, so I would percolate it up. 15, it's correctly placed. 9, it's not correctly placed, so I would pick the maximum. So I have 15. So here on the left side everything is okay, on the right side, sorry. And then I need to get down 9. So obviously 9 is not a maximum because I have 13. So I would place 11 here, 13 here, and then 9 and 7 and 8. And now this is the maximum heap, and then we will do the sorting as we have done. So let's discuss which of these methods is more efficient. So obviously it's the QuickSort, because in the heap sort we have to construct the tree and have to do a lot of percolate down and up. And however here, look well, we have just found the sorted array in just a few steps. So this is it for this exercise. If you have any questions, do not hesitate to drop me a message, and thanks for watching.